Sum and difference formulas. Sum means to add, difference means to subtract. We have 5 or 6 main ones. 2 for sine, 2 for cosine, and 2 for tangent. And the alpha and the beta are just angles. And we're going to use these are the main ones, main 6, to answer some questions. Let's start with find the exact value of 17 pi over 12. Now if you're like me, you don't like working with pi or radians, so I'm going to convert these to degrees to see what we have. So I'm going to times that by 180 degrees over pi. Pi's cancel. And we end up with, and you can convert them to degrees pretty easily, but I'm just going to do it show all the work. So when you do this, we get 255 degrees. Now 255 degrees isn't one of my special angles. 255 degrees is in the third quadrant. And if you're wondering how I know that, is because that's 0, that's 90, that's 180, and that's 270. So 255 is in this third quadrant. Now, my special angles are 30, 45, and 60. So I want to write 255 in terms of special angles, if I can. And I think I can. Now I need both of them to be special angles. So let's see. If I take 255, let's just use information about the third quadrant. I subtract 180. $75, that's not a special angle, so I can't use 180 on 75. Let's just go ahead and do 30. That's what happens. 225, is that a special angle? I do believe it is, and the reason why I know that it is because 225 is the same as 180 minus or plus 45. So somehow, some way, you need to find two special angles for 255, and it's the same as 225 degrees plus 30 degrees. And 225 degrees is actually the same as a 45 degree angle in the third quadrant. So keep that in mind. So we're going to use sine alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. And our alpha and beta are going to be, however you want to arrange them, we're just call it 225 plus 30. And if you want to, you can convert those back into the radians, which I probably should. But just for the sake of not wanting to, I will leave it like this. So my formula has sine 225 degrees, cosine 30 degrees. And really, in all actuality, I've actually already done this, and I'll show you. As far as converting these into radians, I'll show you how I've done that by using this information up here. And then cosine of 225 degrees, sine 30 degrees. I'm just using the formula. Now sine 225, let me show you how I know what the radian measures are. 225 is a 45 degree angle in the third quadrant. And if you don't have these on your unit circle and you have the radians, then you know it's going to be 5 pi fourths, and 30 degrees is pi sixths. Because 30 degree angle comes first from the x-axis. 30 comes first from the x-axis. 45 comes second from the x-axis, no matter which way you go. And so if you are given a unit circle, which you probably will be, what you now want to do is find sine of 225, which is a 45-degree angle in the third quadrant, and sines are negative in there, so that's square root of 2 over 2. In fact, so are cosines. Cosine of 30, so this is multiplication, by the way. This is multiplication. Cosine of 30 is a square root of 3 over 2. That's in the first quadrant, so I know those are positive. Cosine of 225 is the same as sine of 225 because they're both negative in the third quadrant. Sine of 30 is 1/2. And in case you're wondering, once again, 225 is, sine is negative square root 2 over 2. That's the y value. Cosine of 30 is the x value, square root 3 over 2. Cosine of 225 is the x value. And sine of 30 is the y value. And now what we're going to do is clean this up. And we'll be done. So negative square root of 2 times square root of 3 is negative square root of 6 over 2 times 2 is 4. You only keep the denominator when you're adding and subtracting. When you multiply the denominators also. Plus negative 2 times 1 is negative 2 over 2 times 2 is 4. And that's the answer. Well, we can clean it up just a little bit more. We can write it all kinds of ways. Negative square root of 6 minus square root of 2 all over 4. That's good enough. The system should take that. Now look at this example. This one we're not going to do each individual value because if I take 70 plus 20, if you recognize that, that equals 90 degrees, and that's a nice angle on our unit circle, we can go straight to the form. This is in cosine alpha cosine beta minus sine alpha sine beta. And you know what that equals? Cosine cosine minus sine sine is cosine alpha plus beta. And since I was able to add those, it means I can use alpha plus beta. Everything checks out. This is the actual formula. And cosine alpha plus beta, I can add, if we call it alpha 70 and beta 90, I can actually add those and I can use those. So in other words, this is equal, or this right here is, this, I'm using this to verify that all I have to do is add 70 degrees plus 20 degrees, and that equals cosine of 90 degrees, which is the same as pi halves, which is the same as this y-axis, positive y-axis. Cosine is the x value, so cosine of 90 degrees is 0. Now let's look at this example. We're going to find these 4 values using these conditions. So what I want to do first is look at the information about alpha. Now I know that alpha is between 0 and pi halves, which means it's in the first quadrant. So I'm going to draw a rectangle in the first quadrant. Alpha is my angle, and I know that that side is y is 3 and 5 is the r, so I need to find this x, and the way I do that is I use the Pythagorean Theorem. X squared plus 3 squared equals 5 squared. X squared plus 9 equals 16. Subtract the 9. Well, 5 squared isn't 16. Who said such a thing? 5 squared is 25. I was already thinking 16. 25 minus 9 is 16. Square root, and we get x equals 4. So I'm going to erase that x and make it a 4. Now I want some information about my beta angle. Now beta is between 0 and negative pi halves, which is down here. So in the fourth quadrant, so I'm going to draw a right triangle, and there's my angle beta. Now this is x over r, so this is my x, 2 square root of 5, and this is my r, 5. I need to find y. Or you could use adjacent over hypotenuse, but I'm going to use my Pythagorean theorem again. So I'm going to use y squared plus 2 square root of 5. I don't know what that is. Can you see that? Can you read that? I can't read that either. Y squared plus 2 square root of 5. Let's square all that. Equals 5 squared. So we have y squared plus 2 squared is 4. Square root of 5 times square root of 5 is 5. Equals 5 squared is 25. So y squared plus 20 equals 25. Subtract 20. Y squared equals 5. And square root, we get y equals square root of 5. So I'm going to erase that. And that's going to be square root of 5. Looks like an S. My 5s look like S's. Have you noticed that? Now, when I find these four values, sine alpha plus beta, cosine alpha plus beta, sine alpha minus beta, tangent alpha minus beta, these all have sine alpha, sine beta, cosine beta, and tangent alpha, tangent beta. So what I want to do, I want to find those values. So start with sine alpha. Sine alpha, here's my alpha. By the way, this is my beta information. This is my alpha. We split it apart so you won't have to be confused with it. Sine alpha is y over r, which is 3 over 5. Now let's find sine beta. Sine beta is the opposite. In this case, square root of 5 over the hypotenuse, which is 5. Now, before I do that, we're in the fourth quadrant, which means our y values are negative. So let's go ahead and make that a negative square root of 5. So that's going to be negative square root of 5 over 5. I mean, you can label these if you want to. That's x, that's y, that's r to help you. X, y, and r. Sine is y over r. Just find cosine now of alpha. Cosine of alpha is x over r, so it's going to be 4 over 5. Cosine of beta is also x over r. That's going to be 2 square root of 5 over 5. Now let's find tangent alpha. Tangent alpha is y over x, so it's going to be 3 over 4. And then tangent of beta is also y over x, so it's going to be negative square root of 5 over 2 square root of 5. Negative square root of 5 over 2 square root of 5, and these square root of 5s cancel out, leaving negative 1 over 2. So now we're going to use those 6 values to answer all of our questions. So start with, I think it was sine alpha plus beta. Yeah. If you use the formula, which is up above, sine alpha plus beta, this is going to be sine it's going to be sine alpha cosine beta plus cosine alpha sine beta. With sine alpha, we just found was 3/5 times, this multiplication once again, cosine beta, which is 2 square root of 5 over 5, plus cosine alpha, which we found was 4/5, and sine beta is negative square root of 5 over 5. And then let's clean this up. 3 times 2 is 6 square root of 5, and 5 times 5 is 25. 4 times negative square root of 5 is negative 4 square root of 5 over 5 times 5 is 25. Since we have common denominators, we're going to write that as 6 square root of 5. I'm going to write minus 4. In fact, let's just save a step because we have a lot of writing already. 6 square root of 5 plus negative 4 square root of 5 is 2 square root of 5 when you combine like terms over 25. We're done with that one. That's our sine alpha plus beta. Now we want to do cosine alpha plus beta. And I'm going to need a lot of space. A lot of space. Which one are we doing now? Cosine alpha plus beta? Yes. Cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Cosine alpha we found to be 4 over 5. In fact, you know what I'm going to do? Oh, no, I'm not. I was going to erase this so it'll be easier to see, but I'm just going to keep on coming back and forth. Cosine alpha is 4 over 5. Cosine beta is 2. I'm going to mark this so I'll make it a little bit easier to find. Cosine beta is 2 square root of 5 over 5. Minus sine alpha, which is 3/5. And sine beta is negative 5/5. 3/5 times negative square root of 5/5. I have to make sure. Yep. Let's clean this up. 4 times 2 is 8 square root of 5 over 5 times 5, which is 25. Minus, well, minus and a minus, when you multiply, makes that a positive. 3 square root of 5 over 25. We have like denominators, like terms on top, so it becomes 11 square root of 5 over 25. Next one we're asked to find is sine alpha minus beta. So it's going to be sine alpha cosine beta minus cosine alpha sine beta. Sine alpha, I can look right here, sine alpha was 3/5. Cosine beta was 2 square root of 5 over 5. Cosine alpha is 4/5. Times sine beta. Sine beta is negative square root of 5 over 5. Let's clean this one up. 3 times 2 is 6 square root of 5 over 25. Negative times a negative is a positive. 4 square root of 5 over 25, which is equal to 10 square root of 5 over 25. And that reduces down to, because 5 goes in 10 2 times, 5 goes in 25 5 times, 2 square root of 5 over 5. We have another one. One more. And that was tangent alpha minus beta. This is one I'm not for sure if I know it, but I think it's 1 minus tangent alpha tangent beta over, I think 1 plus, but we'll see. Nope, I was wrong. I'm always wrong. Tangent alpha minus tangent beta over 1 plus. Tangent alpha minus tangent beta over 1 plus tangent alpha tangent beta. Let's make sure. Tangent alpha minus tangent beta 1. Yeah, that's right. All we need now is our tangent alpha and tangent beta. 3/4 is tangent alpha and tangent beta is negative 1/2. 3/4 and negative 1/2. 3/4 negative 1/2. 3/4 and negative 1/2. 3/4 negative 1/2. 3/4 negative 1/2. Tangent alpha was 3/4 and tangent beta was negative 1/2. Over 1 plus tangent alpha is 3/4. Tangent beta is negative 1/2. That becomes a plus and a plus. Let me show you how to do these kind of quickly. 3/4 plus 1/2 over 1 plus, I'm actually going to change that, because a positive times a negative is a negative. 3 times 1 is 3, over 4 times 2 is 8. And that's actually over a 1, if you want to think it like that. What's the LCD of 4, 2, and 8? It's 8. Smallest number they all divide into, it's 8. So I'm 1 times that by 8, and 1 times that by 8, times that by 8. I didn't need that 1 down there, but times that by 8. Then we'll reduce. 4 goes into 8 2 times, 2 goes into 8 4 times. These 8's cancel, leaving 2 times 3 is 6, plus 1 times 4 is 4, over 8 times 1 is 8, minus 3. I need just a little bit more space. Six plus 4 is 10. 8 minus 3 is 5. And the final answer is 2. Was that not a fun one or what? Let's leave those problems. Let's go to something more, a little bit more easy. Yeah. It's establishing identities. Now I'm going to use my sine alpha plus beta equals sine alpha cosine beta plus cosine alpha sine beta. So what I'm going to do is I'm going to call this pi halves alpha and theta my b. So I have sine pi halves plus theta equals sine pi halves cosine theta plus cosine pi halves sine theta. Sine of pi halves, if you look at a unit circle, if you use your calculator, you'll see that the answer is 1. And then cosine theta, we leave it as cosine theta. And then cosine of pi halves, you'll see that it is a 0 times sine theta. And 0 times anything is 0. 1 times cosine theta is cosine theta. That's what we're trying to get to. Established. Let's try this one. Let me bring it back up so it won't look near as bad. Okay. Sine alpha plus beta over sine alpha cosine beta. So start the left side. It looks pretty bad. Sine alpha plus beta over sine alpha cosine beta. Using the same identity I just used. Same formula, I should say. That's sine alpha cosine beta plus cosine alpha sine beta over sine alpha cosine beta. Then I'm going to separate my numerator. I'm going to write it as sine alpha cosine beta over sine alpha cosine beta. The reason why I am is I'm trying to get a 1. And I can see that if I divide that by that. And then I'm going to take the other part of the numerator, cosine alpha sine beta, divide that by sine alpha cosine beta. So all that becomes a big O 1 because anything divided by itself is 1. Then if I look at cosine alpha over sine alpha, that's the same as cotangent alpha. And then sine beta over cosine beta would be tangent beta, which is what I'm trying to establish. Not so bad. Here comes a fun one. On this one, you have to use a little trick here. You have inverse sines, inverse cosines, all that fun stuff. Remember those domains and all that good stuff. Actually, the y values, your y values, or these arguments, whatever you want to call them, have to be between -1 and 1. And we have to restrict our sign from negative pi halves to pi halves. Remember that stuff? And then, because the inverse sign is asking for the angle, that gives us 3/5, and it's got to be between negative pi halves and pi halves, and inverse cosine is asking for the angle, it gives us -4/5, so we have to restrict our range. What we're actually doing is, we're restricting the domain of sine and cosine on these angle measures, which actually is the range of the inverse functions. But what we're going to do, we're going to call this alpha, all of sine, or inverse sine 3/5 is our alpha, and we're going to call that beta. So that means that beta is all of inverse cosine -4/5. And what that means is that I now can use sine alpha minus beta, which is sine alpha cosine beta plus cosine alpha sine beta. But the problem is I need to find sine alpha and cosine beta and cosine alpha and sine beta. Well, what I'm going to do is I'm going to use this information to do that. That's what I'm going to use. So let's use this. I like to draw rectangles. I think it makes life easier if you'll see it. So I have sine. I have to look from negative pi halves to pi halves. And since this is all positive, that means I can't use the fourth quadrant because that's got a negative y value. So I'm looking in the first quadrant. Draw my right triangle with my alpha. This is my y, and that's my r. So that's my 5, or that's my 3, and this is my 5. I'm going to use my favorite thing in the world, which is the Pythagorean Theorem. It's really not, but we'll act like it is. Do the same steps as we've done many times. I did the exact same mistake I did earlier. I don't remember if I did it in this video or if I erased the video. I don't know why I'm talking like this. It's late at night. I don't know what that is doing there. Square root I think I've done this before. And so this is now 4. Now I need to do the same thing with my beta. I'm telling you, the triangle probably is the best way to go, just to make sure that you're doing everything correctly. So I know that cosine, inverse cosine, I'm looking at values between 0 and pi. So that's what I'm looking at for my cosine to restrict it. So, well, that's not pi. That's pi halves. Oh, what am I doing? That's pi. 0 pi, first and second quadrants. Cosine is negative in the second quadrant, not the first. So I'm going to be in the second quadrant. I'm going to draw my right triangle. Call that beta. Negative 4 over 5, that's 4, and that's 5. X and R. It's actually a negative 4, but when I did the Pythagorean Theorem, I'm going to think it was a 4. If you look, it's the same triangle. So that automatically tells me that that side is going to be 3. 3, 4, 5 is a 3, 4, 5 triangle. So what I need sine alpha, cosine beta, cosine alpha, sine beta. So let's find those. Sine alpha is going to be 3 over 5. Cosine of beta is going to be 4 over 5. Once again, it's x over r, adjacent over hypotenuse. Sine is opposite over hypotenuse, or y over r. And it's not a 4, it's actually a negative 4. So keep that in mind, it's a negative 4. I'm going to erase that little thing right there. It's a negative 4, going left. Plus I'm in the second quadrant. Cosines are negative in the second quadrant. And then cosine alpha is 4 over 5. And then sine beta is 3 over 5. I'm going to erase that because it looks like it may have a negative sign. And sine isn't negative in the second quadrant. Positive. So now I'm just going to take my values and substitute them into the formula. So, sine of alpha minus beta, I probably should be using the actual problem now. Sine inverse of 3/5 minus cosine, inverse cosine of negative 4/5. Is that what it was? Yep. It's going to equal this. Sine alpha is 3/5 times cosine beta, which is negative 4/5, minus, or plus I should say, well, you need to make sure. No, it's not. It's minus. I was right the first time. Because if that's a minus, then that's a minus in the formula. So it is a minus. It's really easy to mess up those signs. I've warned you about that. Cosine alpha, sine beta, I mean. Cosine alpha is 4/5. Sine beta is 3/5. So that gives us a negative 12 over 25 minus 12 over 25, which gives us the final answer of negative 24 over 25. That's fun, wasn't it?